Hello, geometry students. Today we are starting 9-1 in the book. You can kind of follow along on page 572 if you want something to look at. This section deals with translating or sliding figures, and we're going to learn about something new called vectors. Vectors are a very big part of upper-level mathematics and physics. You will use those frequently. The rest of this chapter you will kind of get a glimpse of upper level math that enables you to use vectors in a very big way. So first I wanted to knock out a couple of vocabulary words. An image is the new figure I've created. So like if I translate something, I'm looking at its image. The pre-image is the thing before I translate it. It's the original figure. However you say that, isometry. Isometry? We'll go with isometry. Is meaning it creates congruent figures. So translations are isometric because they create congruent figures. I'm going to have the same size, same shape when I'm done. Okay? So example 1 in the book says, graph the quadrilateral ABC with vertexes ... Find the image of the vertex after the translation. This part you've already seen before. So that means I'm going to move it right 3, down 1. So I take each point, move it down 3, over 1. And that slides the whole figure. This part should not be new. We've talked about it even. Not a big deal. Okay? Now, vectors, used very frequently in physics, vectors are a little line, so if I was to draw one, that's a vector. It represents both magnitude and direction. So the magnitude, the best example I can think of that's kind of easy for everybody to see is wind. Wind is a vector. So like if you look at a weather map, you're going to see, okay, there's my station. If the wind's not blowing very hard out of the north, it'll have a little arrow. If the wind's howling out of the north, you're going to have a big arrow from the north. Okay? But that denotes both magnitude, how hard the wind's blowing, and direction. Which direction is the wind blowing out of? So here's some new vocabulary. Here's a picture of a vector. The initial point is the starting point, and then that's F. The terminal point is G, or the ending point. The vertical component is how much it changes vertically. The horizontal component is how much it changes horizontal. So very much like slope, all that. The diagram shows, here's how you name it, and if you can't see that very well, it's FG, the initial and terminal point, and then a half arrow on top. That is how you write a vector. And you read that as vector FG. Okay? Component form of this vector, you're going to put the horizontal component in the front and the vertical component in the back. So it's like, how much did your X change? How much did your Y change? And these are not parentheses. This is kind of written with some pointier brackets than parentheses. Okay? So, if the vertices of ABC are 0, 3, 2, 4, and 1, 0, translate ABC using the vector 5, negative 1. So all we're doing is we're adding 5 and subtracting 1 to each thing. So A would now be at 5, negative 2. B would now be at 7, 3. And C would be at 6, negative 1. Okay, and you could draw that, but these are the new points. This is your image. These points would be your pre-image. Okay? So they want you to name the vector and write it in its component form. So, I know that this vector is RS, and I know that its horizontal component is 1, 2, 3, 4, 5, and its vertical is 0. so that's how you name that one. This next one is TX, and it has no horizontal change, and the vertical change, is 3. And then last but not least, this would be DK, because I start at my terminal point, start at my initial point, end at my terminal point. Alright, we changed horizontally 1, 2, 3, 4, 5. And we increased our vertical component by 2. So there's your vectors. Okay? And that's really all there is to this first section. I need you to know the vocabulary very well. If you are done and you have time to spare, I recommend that you take a look at some of the practice problems, because there will be a quiz about this later. Okay? I hope to see you all on Monday. Have a good weekend.